Hello everyone, welcome back to another video. In today's video, we are going to start getting into another important component of Java programming, which is dealing with decisions in your programs. So this video is going to cover basic things that you need to consider and know in order to make decisions within your code. So let's go ahead and jump right in. So, as you may know, when you create programs, they run a certain way. So, currently, how we've been covering it is line by line, your program will run and it will complete a task. But that is not the only way that your program can run. Sometimes you may need to create a program that it needs to do one thing for one item and another thing for another item. So basically, they have to make a decision or they need to choose. So in the real world, we make decisions every day. You make a decision whether, if the light is red, then you're going to stop your car, or at least you should. If you're hungry, you typically eat. If you have to go to work, you generally will get yourself prepared. If you're tired, you would go to sleep. If your battery is low, you would charge it. So every day we are constantly making decisions based off of a certain factor. Now, when it comes to computers making decisions, they actually have to break it down into steps. So every computer is going to make a decision based off of a question, and that question has to be answered with true or false, or the Boolean values of true and false. So the question would basically lead to different outcomes. So for example, when you're working with making a decision, you can create a branch, which is basically a path to one answer or the other, or one outcome or the other. So if you take a look at the screenshot we have here, it says, is it raining? So is it raining is technically a yes or a no question. So based on the response to that question, there will be different actions. So you see here, it says if it is raining, then you need to bring an umbrella. If it's not raining, you need to wear sunglasses, basically saying that it's sunny outside. So based on the answer, there are two different outcomes to the same question, but again, there could be more outcomes than just two. So this is what we like to call a decision tree. So you basically have your question that you're trying to solve. And that question is either going to have the answer of yes or no. So in this case, we have the main question of, is the shop open? So if the shop is open, it's going to then ask, is the line short? If the line is short, then order a coffee. If it's not a short line, then come back later. Now, if the answer was no to is the shop open, basically the person would go home. So this is showing you the decisions you can make based off of a question, and based off of that question, you can have different outcomes or different actions. So before you can actually choose a branch in your program, you must evaluate a question that basically has two possible answers. So that would be true or false. And to make these decisions, your program is going to use something called Boolean expressions. So Boolean expressions are basically a statement that will either be true or false. Hence the fact it is named Boolean expressions, because Boolean represents true or false. So your Boolean expression is typically going to consist of three parts. It's going to have a value or a variable. Then you'll have a comparison operator between that value and the next value that you're using to compare it to. So value, symbol, value. So the comparison operators that you can use in Java are very much so similar to the same ones you can use for everyday math. So less than, greater than, equal to, not equal to, less than, equal to, and greater than equal to. So the concept works the exact same as it does in math in this case. The only thing that is different is the equal to is two equal signs in programming. So if you want to say equal to, it is two equal signs. But other than that, all of the rest of them are pretty much the same. So here is an example of how a Boolean expression is constructed. So you see, first you start with a value, then you would have the comparison operator, and then you would have another value. So in the examples, you see one, we have age is greater than or equal to 18. We also have score is equal to 100. We have grade is less than 60. And we also have temp is less than 60. So these are all examples of Boolean expressions. Why? Because the response has to either be true or false. So either the grade is 70, for example, and if 70 is less than 60, it's pretty much going to check is that true or false. And in that case, if we're saying grade is 70, but we're saying is 70 less than 60, then basically we know that response to that Boolean expression is false. Let's say, for example, score is set to 100. And if we're saying score is equal to 100, then that would be true. So in all of these Boolean expression cases, the result is either going to be true or false. So that is what you have to remember. Now, when you are working with Boolean expressions and strings, it's a little different. So let's say you want to use the equal to with a text value. In this case, because it is a string and it is not necessarily a primitive data type, it uses the string method dot equals, which we covered previously. So the dot equals method is what is used to check to see if a Boolean expression and a string could be the same thing. So if we take a look at our examples, we're saying that the variable color is equals to the value or the string red. So if color is holding the value of red, then it would be true. If it's not, it would be false. Same thing with option. Option is the variable, and you're basically applying the equals method to that string variable to see if the variable value is equal to login. So instead of using the double equal sign, we are using equals method for strings. But when you're making decisions, there will be times that you may want to make more than one decision or one condition. For example, if you're trying to check if a person is a certain age and they can drive, or if you're checking if a number is in a certain range, so if a number is between 12 and 53, or if you're checking to see if a user entered yes or Y as their input. These would be cases where you technically have two different conditions you are trying to check and not just one. So that is where your logical operators come into play. These logical operators allow you to connect the Boolean expressions, allowing you to deal with multiple conditions. So the logical operators you will be working with are going to be and, or, are not. And they will be using those symbols. So and is represented by two and symbols, or is depicted by two of the straight line symbols. And then you also have your exclamation for not. But these would be logical operators that you can use very much similar to your comparison operators. Now, each operator or each logical operator has a different outcome. So your and operator is going to be true if both are true. So all conditions must be met for it to be true. So basically saying this and this has to be true. So if one of them is false, then the whole thing is false. So and means both. Now, or means that one has to be true. So either this condition is true or that condition is true. If one of them is true, then it can work out. If both of them are false, then nothing will happen. So this is not a case where they both have to be true. You can have one that is false, you can have one that is true. And as long as one is true, then you will be able to work with that condition. And lastly, you have the not. Generally, this is not used as much as the others, but it is used when you need to reverse the value of true or false. So it's basically used to just check the opposite of the specific condition that you are checking. So again, a little more to the rarely used side, but it does exist in case you need it. So when you're using your logical operators, again, it's going to work the same way as our Boolean expressions, except this time we are having or using two Boolean expressions at minimum. We're using two Boolean expressions to work together and they combine using a logical operator. So if you take a look at these examples, then you see we have age is greater than 18. That is expression 1. Then you see we have age is less than or equal to 21. That is expression 2. To join two Boolean expressions together, you place the logical operator in between it. So basically in this case, it's saying if age is greater than 18 and if age is less than or equal to 21, then this can happen. That's what the first example is stating. Now with the or, it's basically saying if expression 1 is true or expression 2 is true, then we're going to do this. So that is the general overview of how you can use your comparison and logical operators to help you make decisions in your program, which then can be later applied in other ways. So what is the difference between a Boolean expression and a condition? So you have heard me say them both multiple times in this presentation. So what you need to know is that your Boolean expression is basically what you consider a statement that is going to be true or false. So this is just purely logic, nothing more. Whereas your condition is going to be a Boolean expression that's used inside of a control structure within your code. So this condition deals more with the coding that you are completing, while a Boolean expression can basically just be a general piece of logic. Now, getting into a conditional is a control structure that uses a condition to decide which code to run. So it's basically what's responsible for performing the decision making that will be occurring in your code. So how do we piece these together? Your Boolean expression, let's consider those the building blocks of decision making. So you start with your Boolean expressions. You then use those expressions within your conditions, and once you have the condition nulls will act on them or complete a certain task based on the result of those conditions. So today we have basically started getting into looking at how we work with decisions in our Java programs. Of course, there are going to be times we're going to have to make multiple decisions in our code, and this is how you would break that down. The main components I would say you really need to grab concept of would be those Boolean expressions, as well as your operators and your logical and comparison operators. Once you have a strong foundation of how they work and how they combine, you should be set up and ready to go to start working a little bit deeper in your code and working with decisions. So in our next video, we are going to start looking at how we can use decision making within Java. So I will see you in the next video.